This is 3.3, day 2. We're going to continue working with those logarithms. Yesterday we introduced the properties of those logarithms where we expanded those logarithms out. The first part of our lesson is we're going to compact them back together into a condensed form. Then we're going to use the properties from a few days ago and yesterday to simplify logarithms. All right. So yesterday, our final answers at the last part of our lesson were problems that looked like this. Now we're going to condense them back together. So the first example I have is 1/2 the logarithm of base 10 of x plus 3 logarithm base 10 of x plus 1. So what do we want to do first?
Move the numbers that are in front of the log.
Yes, move the numbers that are in front of those logarithms to where? Up to the top as exponents, as powers. So we're going to push this 1/2 up to here. We're going to push that 3 up to there as powers. So now I have x to the 1/2 power plus a logarithm of base 10, x plus 1 cubed. What else can I do?
Multiply.
Multiply? I can combine them together. Okay, shut your textbooks up. Focus on the lesson, please. Thank you. So now we said we could combine those two logarithms together by multiplying because I have a plus between those logarithms. Times which one?
X plus 1 cubed.
X plus 1 cubed. I can't combine them together if they're separate or different bases. So like if this is a base 10 and that was a base 2. Can I do anything else to clean it up? How about that 1/2 power? Square root. You can sit wherever. All right. So there's the first example. Let's go on and do second example. We have two natural logarithms. What are their bases?
10.
E. They're base E. Can I combine these logarithms back together? Yes. How would I do that? Division. What else can I do? Move the 2 back up. So I tend to do the powers first and then combine back together. It's just kind of out of habit. So I want to push that back up as a power. So now it's the natural log of x plus 2 squared minus the natural log of x. And then you said I can combine those two natural logs back together by division. Can I cancel an x out?
No.
No.
If it was a mole.
If there was a multiplication symbol between that x and 2, and we leave it alone.
It's just over x, not power of x.
Pardon me?
It's
No,
just over
because this is the whole thing.
Oh, yeah, no.
If you like to throw brackets, you can do so. You don't need them though. Question C. What do I want to do there? Move the 1/3 back up to a power, and what else?
And then multiply x and x plus 1.
Yeah. So I bring that 1/3 back up to a power. a power of 1/3. And then you said I can add the two logarithms back together by multiplication. So I have x times
X plus 1.
x plus 1.
Can you distribute them? Or
Yes, you can.
you want us to?
I would. And then what's that 1/3 mean?
To the cube root.
Cube root. And then cube root this. Like my black today. Marker. Cube root. All right. So that is the opposite of what we did yesterday in our lesson where we expanded them out. Now we're condensing them back together. To review with you, these properties are already in your notes. We're going to use these properties on the next slide's examples. So we have logarithm properties in base, any base, and then we have the ones that we learned. These are what we learned yesterday. They're in your notes. Okay, first example. We want to evaluate these logarithms without the use of a calculator. Now remember, your next quiz is non-calculator. So we want to use these properties to help us to reduce. So the first problem we'll do is a logarithm of base 5 of 125th. We want to rewrite it in different forms so we can reduce it down to a simplified answer. What is one thing we might be able to do? Now it works. This black marker thinks it's still on. I can't move it. Look at it.
Should I put it back down?
Put it back down again.
Now the light's on.
Now the light's on.
Can I put it up?
What?
It's a sensor thing. There was an eraser in the sensor. Someone's being funny. All right. Push this down. Yes, what can I do?
Could you do like 5 to the x equals 125?
You're really close, yes. We could reduce it. So it looks like this, log base 5 of 1 over 5 cubed. Do you agree with that? 5 times 5 times 5 is 125. And then can I rewrite that as a negative exponent? So it looks like this. 5 to the negative third. Now there's two different ways you can go with it. You can either bring the negative down in front, or you can leave it. Now let's go back to this slide. Which property will now help us on this slide? The 1, 2, 3, 4 on the right, or the 1, 2, 3 on the left? You guys don't want to speak. 1, 2, 3 on the left, the third one. Good job. You know you're being recorded. So what will be my answer now? They are inverses of each other. -3. You guys are shy when you guys video record.
3 is now negative because you had more.
Yes, they inverse each other because I have a logarithm of base 5. I have an exponential of base 5. My poor second hour gets recorded all the time. All right, let's go to number 2. Logarithm base 2, 5th root of 8. How can I rewrite that?
Can you raise it to the 1/5 power?
Very good. Raise it to the 1/5 power. So now it's 8 to the 1/5. What else can I do? What can I do with that 1/5 power? Bring it in front, great job. Now, let's focus on the log base 2 of 8. What can I do to rewrite there?
2 to the x equals
How can I rewrite that 8? What'd you say?
2 to the x equals
2 to the, very good, 2 to the third. How can I reduce next? Log base 2 of 2 to the third. You can bring the power to the front, or inverse it. Log base 2 of 2 to the third is 3. And then 3 times 1/5, 3/5. All right, last example today. What can I do with this example?
divide.
Divide, very good. I have the same base, and the logarithms are subtracting, so we learned yesterday that we can divide those. So log base 4 of 32 over 2, good. Now what can I do to reduce it? 32 divided by 2? 16, good. All right.
16 to the, or 4
So
squared.
can I rewrite 16 is what you're looking for to a base of 4?
Squared.
Yep, 4 squared, good. So you can use that inverse property is what you're looking for.
And then 4 is
Log base 4 of 4 squared. Now they're inverses, so our final answer is
2.
2. Good job. Here is your homework for today. 3.3, day 2, 39 through 79 odd.